Then let's take a look about the question. About the question 1139 largest one-border square given to a 2D grid of zeros and ones. Return the numbers of elements in the largest square subgrid that has all one on the border, or one if subgrid doesn't exist in the grid. Example 1, input grid 111, 101, 111. In example 2, grid 1100, output 1. So for this example, and we can take a look about the code. The code aims to solve the problem of finding the largest one border square in a 2D grid of 1 and 0. One border to make sure the border is all 1, right? Which is all element is on the border are 1, and any element inside the border can be either 1 or 0. K functions these functions populate the grid G with prefix sum. It related through each cell in the grid, the build, right? Each cell in the grid, right? Or we can take a look at the largest border square first. This one, right? Implement the call algorithm to define the largest one border square. Iterate through every possible left corner A and B, and every possible right bottom corner C, D, to check whether a square exists that is larger than the current largest known square. Detailed explanations. Step 1, to calculate the prefix sum, the build function. The function calculates the prefix sum for the 2D grid. For each cell I and G, it adds the value above I minus 1 G and the value I G minus 1. And then subtract the value diagonally above and to the left I minus 1 and G minus 1. Step 2 is to check for any ones in the grid. Before starting the search, the code checks whether there are any ones in the grid at all. If there is any one in the grid at all, if not, it returns 0 immediately. We can see in here, if there is no any one, then return 0 immediately. Step 3 is to search the largest one border square in the function. We initialize the answer first with 1. Assume at least one border square exists. Assume at least one bordered square exists. Then for each A and B, we loop through every possible bottom right corner C, D of the square, starting from the sides that are larger than the current answer. We use the prefix sum grid to quickly check if the border of the square has all 1 by using sum function. Has all 1 by checking the sum function. Specifically check if the sum of the full square minus the sum of the inner square. Sum of the full square minus the inner square. Sum of the inner square equal to the number of ones should be on the border of the squares of its size. The number of I should be on the border of the square of its size. Step 4 is return the largest square area. Finally, the function returns the area of largest square found on answer multiply answer the sample wrong. So this is the whole solution of the Leetcode 1139.